So here, welcome to the first most important part of the workshop. So understanding the basic terms and stuff. So this is the most commonly used interface, the IIC, or you can call it I2C. So this is the inter-integrated circuit bus. So basically this whole thing works on serial data and serial clock connected to the controller and the peripheral. So each controller and the peripheral have these common connections between them. So the interconnected ICs can be toggled using the same data and same frequency. So this is the working. So there are two controllers. So we have given the same data and the clock signal to the controller and the peripheral. So when the controller responds with the data, and one more controller can be welcome to the first and the most important part of the lecture. So we are going to understand some basic terminologies and basic interface types. So this is the most commonly used interface, the IIC, or you can call it I2C or I2C, meaning inter-integrated circuits. Basically these are circuits which integrated circuits which are like commonly connected with serial data and serial clock. So this here is a controller, and this can be used to toggle a peripheral or its surrounding components using the same data. So these are two controllers, and we have supplied a serial data and serial clock to both of them. So these can be used to toggle or operate using the same data and clock. On the other hand, we have our pull-up resistor and a pull-down resistor. So basically pull-up resistor helps the value to be increased, and as you can see, this is the amplifier. So the main reason for amplifier, so as you can see, we have our amplifier. So this is probably a feedback amplifier. So basically the values can be rectified. So and basically an amplifier increases or sets the magnitude higher, so the amplitude or the magnitude can be increased. And in a feedback amplifier, the values can be taken in and it can be rectified and can be processed again. So there will be more corrections to the past amplifications. So here, and we're going to talking about the serial and so this is data transmission. So this is a parallel data transmission. So if this is the sender and there is a receiver, so all bits are simultaneously passed over to the receiver. So the bits are transferred parallelly, so there can be minor jumping of signals, and if the signals are jumped, there can be interruptions between different types of bits. So in case the bits are During high frequencies, the bits are transferred at a high speed rate. So the bits here are moving parallelly. So in case if there are interaction between any other bits, they can be reversed and the output value can be faulty or um, can have compiler issues. So and the use of PWM, so a pulse width modulation, basically. So basically this duty cycle you can see here. So the data can, basically the pulse width modulation is used to convert or try to make digital. So basically digital is zeros and ones. So there is like a low input stage or no input stage and a high input stage. So basically one represents the output is turned on and 0 is basically turned off. So in analog there can be a gradient type of operations. So in case you want to, if this is 5 volt and you have to basically dim or increase the value of an LED, so you can have it increasing exponentially or linearly as long as per your directions. So analog is basically a continuous signal, so there are no input interruptions between each signal. So there are this example, if you take this as 1 volt and this 2 volt, so you can have voltage variation between 1 and 2 volts. So you can have a gradient if you keep on increasing the voltage, so the LED can get dimmer or it can get brighter by your signal commands. So this whole PWM can be used for analog conventions. And here we're going to talk about the basic Wi-Fi module. So here is the main microchip and here is another IC. So this is an external crystal clock. So basically external crystal clocks are used to have a decent amount of frequencies which can help data transmit or receive in faster or slower rates. So each micro IC integrated circuits, IC or chips, have an internal clock signal. So basically internal clock varies from 2 or 4 megahertz, 8 megahertz, and external oscillator clock is used to increase or decrease the interruption rates. And this is the antenna, so it basically helps to transmit and receive data. So this is the Wi-Fi module. So ISM stands for Industrial Science and Medicine radio frequency range. So this works on 2.4 megahertz. Sorry, 2.4 gigahertz. So yeah, here you can see the ISM 2.4 gigahertz and the power amplification as 25 decibels in milliwatt. So here we can see the schematic of this whole Wi-Fi module. So the general input output means GPIO, general purpose input output. So we have 1, 2, 3. So there are like 22 pins. So this is basically transmitter receiver. So SPI serial peripheral interface. So here is the ground. Again we have general input output purpose pins. So VCC. So here you supply voltage, and this is an ADC, analog to digital converter. So mainly these are the main important parts to remember. And yeah, this is um, so basically this is the USB bus converter. So here this integrated circuits, this can convert universal synchronous data which is transferred from a USB to serial bits. So you can convert this the received data to the required bits. So basically looking at the converter, we have this schematic. This is the ground, transmitter, receiver. So again there is voltage, and so there's continuous clock. This is VCC. So that's it. So that's it on the main today's shop. Thank you.